For this activity, we'll need a straight edge and something to write on again. I took the liberty of locating a point on the paper. I did my two-fold technique and I put a point there, and I'm going to draw a circle. Now I've lightly traced it with my compass. I'm going to draw this circle, and what I'll do is I'll make sure that I have my x-axis and my y-axis drawn on here as well. You can do that. Alright, I drew those in, and when we divide a circle up into equal increments, there's a couple different ways we can do it conveniently. The one we talked about, this was convenient in a sense that our real number line maps out really conveniently on the piece of paper, or on the circle rather, which I drew on the piece of paper, but we are actually mapping out 2 pi. Radian is 1 rotation. 2 pi is 1 rotation. So I'm going to make a little note of that, and that was from our earlier work here. 2 pi is 1 rotation. So I'll just put a little reminder. Note 2 pi is equal to 1 rotation. Rotation. There we go. When we're talking radian, right? So radian measure. When we used radian measure, 2 pi is 1 rotation. So I'll just put radian in parentheses here. 2 pi radian is 1 rotation. And of course, another convenient way to divide this circle is to cut it into different number of parts. So this is kind of an interesting one here. How many parts should we divide the circle into? Well, this is kind of an interesting question. We have an automatic response to that, and it's like, let's divide it into 360 parts. Right? That's our automatic response. But why 360? Have you ever wondered why we had 60 seconds in a minute? 60 minutes in an hour? Well, it actually comes from the Babylonians. They used a base 60 system. That's very convenient. Why did they choose a base 60 system instead of the very convenient base 10 that we're used to? Well, 60 divides equally by many more numbers. In fact, think of the different numbers you can divide 60 by. Let's think of it in our head. Certainly you can divide it by 1. That's always true. Well, 2, 3, 4, 5, 6, not 7 or 8 or 9, but 10, yes. So you got 1, 2, 3, 4, 5, 6, 10. Not 11, but you can do it by 12, 15, 20, 30, 60. So it's very convenient for us to use this base 60 system that we inherited from the Babylonians. So if you've wondered why 360, well, there you go. So we're going to do that. We're going to let 1 rotation be 360 equal size parts along here. Now I'm going to use a protractor to mark off some convenient ones. Now convenient, I suppose that's a bit subjective, right? But I'm thinking convenient would be, and I'm going to put little dots here, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees. There we go. I'm going to mark those off. Now I'm going to mark them off here at the same time by just making sure my straight edge will go through this mark that I made just for a reference, and then I can find those values here and here. So I just make a little note. Here's the 30-degree rotation this way, and I've got 30 degrees rotation beyond 180 degrees. Draw this, and I'm just going to make this point intercept this point, or not the point, but I'm going to let this line intercept the point here and the point here, and then it'll intercept the circle right down here. So I can mark that. There we go. And so we'll mark that. We'll do the same on this one. Alright, I've mapped those out. Let's use that little marking dot. We'll recycle it a little bit. 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then I'll go all the way around. There we go. So we've divided it into 360 parts. Now in degree measure, there's 360, and then I'll use the little symbol right here for degrees, and that's one rotation. So what we'll do is we'll want to make sure that we know 2 pi and 360 degrees are both one rotation. So our takeaway here is 2 pi is equal to 360 degrees. Grab a highlighter, highlight that on your piece of paper, and then securely lock it in your head forever. 2 pi radian is equal to 360 degrees. So what I'm going to do now is I'm going to map out 0 degrees is 0 radian. 180 degrees, I'm going to do that one first because I'm going to divide both sides by 2. If I divide 2 pi by 2, and 360 divided by 2 is 180. 180 degrees is pi radian. So I'm going to put the radian measure, I'll put in red. This is pi. Well, 90 degrees is half of 180, 90 degrees, so it's half of pi. This is commonly written as pi over 2, but notice that pi divided by 2 is about 1.57. Well, this makes pretty good sense. When we were drawing this out, do you remember how in a previous part we had 1 radian here and 2 radians over here? Well, this right in the middle here is a little bit more than 1.5 radians. It's actually 1.5707.963. Well, it's irrational, so I can't write it out exactly as a decimal, and that's why we use the pi over 2. But just a little reminder, that's about 1.57, and just like pi is about 3.14 radian. And so let's keep going. Let's map all of these out. I think I'll pick one right here, a convenient one. 45 degrees is half of pi over 2. So if I multiply pi over 2 times 1/2, pi over 2 times 1/2, pi over 2 times 1/2 is pi over 4. Now this becomes very convenient. Pi over 4 is this right here. And we'll remember from our previous work that when we look at pi over 4, it's going to be less than 1 radian. So let's take our calculator and look at pi over 4. Pi over 4 is about 0.79 radian. But again, it's irrational, so we like to say pi over 4. So I'm going to circle these radian measurements, and then I'm going to go back and I'm going to circle all of my degree measurements, because I want to know just by quickly looking at a circle, if I'm thinking 270 degrees, I'm thinking pi plus 1/2, which would be 1.5 pi. We could write it as 3/2 pi, like this. I want to know these together very well, just like I want to know these and these. And of course, if I go all the way around the circle, I've went pi plus pi, I've went 2 pi. So 2 pi is the same as the 360 degrees, which of course is what we knew from our previous work. Well, let's put another one on here for good measure. This one right over here, for instance. Let's see how easy it is to find 225 degrees when you know it's 1/4 of a pi past pi. So pi plus 1/4 pi, pi plus 1/4 pi. Well, let's just turn 1 pi into 4 over 4 pi. Now we can add the numerators. 4 and 1 is 5. 5/4 pi. And that's what this value is here. 5/4 pi. And I'm going to circle it. Then I'll circle the equivalent degree measurement. Take a moment now and complete the rest of this. Oh, you say you want one more? All right, no problem. Let's do 30 degrees. 30 degrees. So what I'll do is I want to find what radian measurement is 30 degrees. I could take something I know, like this. 180 degrees is equal to pi radian. Now what I'm looking for is what is the radian measure at 30 degrees. Well, if I multiply this side by 1/6, 1/6 of 180 is 30 degrees. I just multiply this side by 1/6 as well, so I get 30 degrees is equal to 1/6 pi, or commonly written pi over 6. Alright, let's finish that up. Alright, I think we've got it.